I am Dr. Chinnaro. Today we will discuss about Lagrange's mean value theorem. Lagrange's mean value theorem: if a function f of x is continuous on closed interval ab, derivable on open interval ab, then there exists at least one point c belongs to interval ab such that f dash equal to f of b minus f of a by b minus a. And also second form, maybe it is useful for 2 marks also, and sometimes we are using second form and by solving the problems. F of x is continuous in closed interval a comma a plus h, derivable in open interval a plus a comma a plus h, then there is at least one number theta belongs to open interval 0 comma 1 such that f of a plus h equal to f of a plus h f dash a plus theta h. This geometrical interpretation is the tangent at C which is parallel to the chord AB. Here the tangent at C1 parallel to the chord AB, tangent at C2 parallel to the chord AB, tangent at C3 parallel to the chord AB, tangent at C4 parallel to the chord. So if a function satisfies these two conditions, then there is at least one tangent which is parallel to the chord AB. This is geometrical interpretation. Now we'll go for verifying Lagrange's mean value theorem. Fx equal to 5x square plus 7x plus 6 in closed interval 3 comma 4. Since it is polynomial, therefore every polynomial is continuous as well as derivable. Clearly fx is continuous and differentiable in closed interval 3 comma 4. All the conditions of Lagrange's mean value theorem are satisfied. Then there exists a point C in open interval 3 comma 4 such that f dash equal to f of 4 minus f of a 3 minus 4 minus, that is f dash equal to f of b minus f of a by b minus a. Now f dash x, fx is what? 5x square plus 7x plus 6. Now f dash x is 5 into 2x, 10x, 7x derivative is 7 and 6 derivative is 0. Now equate this, f dash equal to f of 4 minus f of 3 by 4 minus 3. F dash c here 10c plus 7 is equal to f of 4 is 114, f of 3 is 72. So you can find c is equal to 3.5. 3.5 lies between 3 and 4. Hence verified Lagrange's mean value theorem. Verifying Lagrange's mean value theorem for f of x equal to e power minus x in closed interval minus 1 comma 1. It is continuous and differentiable in closed interval minus 1 comma 1. Therefore, by Lagrange's mean value theorem, there exists a point C in open interval minus 1 comma 1 such that f dash equal to f of 1 minus f of minus 1 by 1 minus of minus 1. Because f dash equal to fb minus fa by b minus a. Here a is minus 1, b is 1. Now f dash equal to f of 1 minus f of minus 1 by 1 minus of minus 1 is f dash x is minus e power minus x. In that you put x for c. F of 1 e power minus 1 minus f of minus 1 put e power minus of minus 1 which is plus 1. 1 minus of minus 1. So e power c equal to e power minus 1 can be written as 1 by e. E power minus 1 is 1 by e minus e power 1. So take LCM 1 minus e square by e by 2. Now supply minus. Now take reciprocal. E power c equal to 2c e by e square minus 1. So c is equal to log 2e by e square minus 1. The value is minus 0.161, which is lies between minus 1 comma 1. Hence verified Lagrange's mean value theorem. Prove that log 1 plus x is equal to x by 1 plus theta x, 0 less than theta less than 1, and hence deduce that x by 1 plus x log of 1 plus x less than x for x greater than a. Now we consider a function f of x as log 1 plus x. F dash x, derivative of log x is 1 by x and 1 plus x derivative is 1. Now take second form of Lagrange's mean value theorem. F of a plus h equal to f of a plus h f dash a plus theta h. Here taking a is 0 and h is equal to x. You put a for 0, h for x. So f of 0 plus x, f of x equal to f of 0 plus x f dash theta x. F of x is what? Log 1 plus x equal to f of 0 is log 1 plus 0 plus x f dash theta x. Here f dash x is 1 by 1 plus x, put x for theta x, we can get this. Since log 1 is 0, log 1 plus x, log 1 is 0, x by 1 plus theta x. So we proved log 1 plus x is equal to x by 1 plus theta x, where theta lies between 0 comma 1. Now to proving this, since 0 less than theta less than 1, theta lies between 0 and 1. Now multiplying with x on both sides, because x is greater than 0, so inequality never changes, because as x greater than 0, 0 less than theta x less than x. Now adding 1 on both sides, 1 less than 1 plus theta x less than 1 plus x. Now take reciprocal. When you take reciprocal, then inequality will be reverted. 1 by 1 is 1 greater than 1 by 1 plus theta x greater than 1 by 1 plus x. Now 1 by 1 plus x is less than 1 by 1 plus theta x less than 1. So when you write right to left, then inequality will be changes. So now multiply with x on both sides. So inequality will not change, because as x greater than 0. Since log 1 plus x as x by 1 plus theta x. as we proved previous. Therefore, x by 1 plus x less than log 1 plus x less than x. Hence proved. If a less than b, prove that b minus a by 1 plus b square less than tan inverse b minus tan inverse a less than b minus a by 1 plus a square. Using Lagrange's mean value theorem, deduce the following. Okay. For proving these type of problems, we consider function. Here the problem involved tan inverse. So you take f of x equal to tan inverse x in closed interval a comma b. Okay. It is inverse trigonometric function. So it is continuous in closed interval a b and derivable in open interval a b. By Lagrange's mean value theorem, there exists C belongs to open interval such that f dash equal to f of b minus f of a by b minus a. Now, f of x is tan inverse x, f dash x is 1 by 1 plus x square. F dash c for what? 1 by 1 plus c square. Put c x for c. Now, you consider f dash equal to fb minus fa by b minus a. F dash c for what? 1 by 1 plus c square is equal to tan inverse b minus tan inverse a by b minus a. So, since c lies between a and b, okay, squaring on both sides, a square less than c square less than b square. That implies adding 1 on both sides, 1 plus a square less than 1 plus c square less than 1 plus. Now take reciprocal. When you take reciprocal, then inequality will be reverted. 1 by 1 plus a square greater than 1 by 1 plus a square greater than 1 by 1 plus b square. Now right to left, inequality will be changed. 1 by 1 plus b square less than 1 by 1 plus c square less than 1 by 1 plus. You take as equation 2. From 1 and 2, we write 1 by 1 plus c square as tan inverse b minus tan inverse a by b minus a. You put 1 in 2. From 1 and 2, 1 by 1 plus b square less than tan inverse b minus tan inverse a by b minus a less than 1 by 1 plus a square. Yes, what we have to prove? B minus a by 1 plus b square less than tan inverse b minus tan inverse a by b minus a by 1 plus a square. Yes. So multiplying with b minus a on both sides. Yes, we got the result. Now to get deduction, pi by 4 plus 3 by 25 less than tan inverse 4 by 3 less than pi by 4 plus 1 by 6. To get this, simply you take the result, okay, put a equal to 1, b equal to 4 by 3. A equal to 1, b equal to 4 by 3. So substituting in the above relation, you can get like this. Then simplify. Tan inverse 1 is pi by 4. Tan inverse 4 by 3 is as it is. Now adding pi by 4 on both sides. 3 by 25 plus pi by 4 less than tan inverse 4 by 3 less than pi by 4 plus 1 by 6. Hence proved. Next one is put a equal to 1, b equal to 2 in the above relation. 2 minus 1 by 1 plus t square less than tan inverse 2 minus tan inverse 1 less than 2 minus 1 by 1 plus 1 square. This is same. 2 minus 1 is 1. 1 by 5 less than tan inverse 2. Tan inverse 1 is pi by 4. Now again adding pi by 4 on both sides. This is. Now take LCM. You can get the result. That's enough. Also, show that for any x greater than 0, 1 plus x less than e power x less than 1 plus x e power x. Here the function involved e power x. So take e power x as a function in closed interval 0 comma x. It is a exponential function, so it is continuous in closed interval 0 comma x and derivable in open interval. By Lagrange's mean value theorem, there is a, a number in between a comma b. That is, here a is 0, b is x. C belongs to open interval 0 comma x such that f dash equal to f of b minus f of a by b minus a. Here a is 0, b is x. So e power x derivative is e power x. Put x for c. Fx is e power x. F of 0 e power 0 by x. Now e power x minus 1 by x, since 0 less than c less than x. E power 0 less than e power c less than e power x. E power 0 is 1 less than e power c less than e power x. We know that e power c is what? E power x minus 1 by x. You put it here. Now multiplying with the x on both sides, you get this. Now adding 1 on both sides. 1 plus x less than e power x minus 1 plus 1 less than 1 plus x e power x. You have the result. Prove using mean value theorem modulus sin u minus sin v less than or equal to u minus v. Okay. So for proving this, we have two possibilities: u equal to v and u greater than v. When u is equal to v, there is nothing to prove. If u greater than v, then consider the function f of u is equal to sin u in closed interval v comma u. It is a trigonometric function, so it is continuous in closed interval v comma u and derivable in open interval v comma u. By Lagrange's mean value theorem, there is a number c in between v comma u such that f dash equal to f of u minus f of v by u minus v. Now f dash equal to fu minus fv by u minus v. Now you write this relation and find c. F dash c, f of u is sin u, derivative of sin u is cos u, and f of u is sin u minus sin v by u minus v. Since cos u lies between minus 1 and 1, that is modulus cos u less than or equal to 1. What is cos u here? Sin u minus sin v by u minus v less than or equal to 1. So mod a by b is equal to mod a by mod b. According to that, mod of sin u minus sin v by mod u minus v less than or equal to 1. Now take cross multiplication we have. If v greater than u, then you write u for v and v for u. So we have a relation modulus minus x equal to x. Modulus of minus x equal to mod x. So replace v for u and that means you take minus common, sin u minus sin v, u minus v, because modulus of minus x is mod x. That's enough. Calculate approximately fifth root of 245 by using Lagrange's mean value theorem. So for finding approximate values, you just find where it satisfies. Fifth root of 245, that is, you take f of x as fifth root x, that is x power 1 by 5 in 243, closed interval 243 comma 245, because 243 whole power 1 by 5 is 3. You take a number which is valid number. Okay. So here a is equal to 243, a plus h is equal to 245. That implies h is equal to 2. Right. Fx is continuous in closed interval 243 comma 245, and f dash x is 1 by 5 x power minus 4 by 5. It exists in open interval 243 comma 245. That is derivable in open interval 243 comma 245. By Lagrange's mean value theorem, f of a plus h equal to f of a plus hf dash c. Here we take c is equal to 243. Already we know that a plus h is equal to 245. You put it here. You take c as 240 because it is simplified by fifth root. Fifth root of 243 is 3. Okay, you take a number which is comfortable. So 243, f of 243 means you put x for 243, 243 whole power 1 by 5 plus 2 by 5, 243 whole power minus 4. That is v power 5. So 5 5 got cancelled 3, 2 by 5, 5 5 got cancelled, 3 power minus 4, 3 power minus 4 is 1 by 81. So 3 plus 2 by 405 is 0.0049. So now add this. It is approximately equal to 3.0049. This is the value fifth root of 245. This is a homework problem. Pi by 6 plus 1 by 5 root 3 less than sin over 3 by 5 less than pi by 6 plus 1 by 8. Hint, f of x equal to sin inverse x in closed interval. A is equal to 1 by 2, B is equal to 1 by 3. Thank you very much.